Much like variables themselves, another thing that it's common to see beginner tutorials about in computer science are if statements. Those you've probably seen before once in a while. Would look something like if condition is equal to true, then do something inside this set of curly braces. You might also see these joined with an else statement, which is the code that will happen if the condition is not true. You also may see something like else if, like this. As a bit of a technical note, this does not actually exist. Else if does not exist. This is simply an else statement followed immediately by another if statement. Some programming languages like Ruby will join together else if like this in a elif statement, or occasionally in else if statement, but more often than not, it's just else if, and there's no such thing as else if, it's just else followed by another if. Anyway, something that tends to get far less attention, something that tends to get far less attention in computer science tutorial videos is exactly what this condition in the if statement is. On the surface, it's pretty straightforward. You just have a one statement, and then you are checking to see if that statement is equal to another statement. You can, of course, use a bunch of other logical operations like greater than or equal, less than or equal, just less than, not equal. There's also the little known this, these two matching angle brackets here. This is shorthand for not equals. I'm not sure where that symbol originates from, but you still see it occasionally in things like spreadsheet software, and GameMaker language does indeed support angle brackets like that for not equals. It's pretty straightforward, right? I know that you're all looking at the timestamp on the video right now, and you can all tell from the amount of time that I'm going to spend talking about that this is indeed not this simple. Hello all you crazy people out there, my name is Michael. I like wizards, dragons, making games, and making everything more complicated than it has to be. Today we're going to talk about truth values. So anything that you might try to put inside the condition of this if statement has something called a truth value. And truth values are fairly simple. All they do is indicate whether or not something should be considered true by the computer or false by the computer. Different computer languages treat this in different ways. JavaScript is famously kind of a mess when it comes to truth values. In some languages like C or C++, basically everything is considered a number, either a literal number or a pointer. In yet other languages like Java, there are dedicated true-false types, and you can only actually use a true-false Boolean type in the condition of an if statement. We are going to put all those aside for now and talk about how GameMaker language treats the matter. Let's start by putting some things in this block of code. I am going to get rid of this extra if statement over here because that's not actually going to be part of this video. Let's leave this here for now and say if condition is true, show message. The condition is true, else show message. The condition is false. Condition up here is not defined right now. If I were to run this game, then it would break because this variable does not exist, and GameMaker would not know what to do, and it would just throw its hands in the air and surrender. So let's define condition. Let's just set that equal to true. And we can see that indeed true equals true is true. It evaluates true. And how many times can I say the word true in a single sentence before I start to hate my life? If you wanted to set this to false, you can set it to false. We're going to see that the condition is false. Okay, this is if statements. This is pretty straightforward. I hope you've all seen this before. You can simplify this. You can, instead of saying if condition equals true, you can just say if condition, because this statement itself is either true or false if it is a Boolean value, and that is basically the same thing as we had before. This, in the field of logical mathematics, formal logic, whatever you want to call it, would be considered a tautology, because true equals true is kind of redundant. Anyway, we can run the game again, and we're going to see that this condition is false, because false indeed has a truth value of false. It is considered to be falsy. It is not considered to be truthy. Okay, that felt a bit long and circular and kind of pointless, but it's something to start with. Let's put something else in this condition. So, this is, by the way, this is just I'm basically continuing off of last week's video that I made about data types. So you can see there's a bunch of data types in this script, and it's not really going to matter. I'm just going to separate that with a nice comment line. What about numbers? So there's a bunch of different number types in GameMaker, as I discussed in last week's video. There's the regular double precision floating point numbers, there are 32-bit integers, there are 64-bit integers. For the purposes of this video, all numbers are going to be considered the same. I'm just going to call them numbers. I'm not going to bother with the different number types because GameMaker treats them all the same as far as their truth values go. So let's pick a number. Let's say 10. No, let's say 1. We'll go with 1 for now. So 1 is famously shorthand for true. 0 is famously shorthand for false. For a lot of people, for a lot of systems. And that's fine. In GameMaker, true and false are literally just macro definitions for 1 and 0. So if you were to type true, this condition would literally be equal to 1. If you were to type false, condition would literally be equal to false. There are Boolean types in GameMaker. Those suck. Refer to last week's video for more information. Let's go with 1. So because this is actually just literally the macro definition of true, 1 is going to equal true, and we will see that if we were instead to do this with false, 0 would be equal to false. There are, of course, many other numbers that you can assign to a variable, not just 0 and 1 in GameMaker. You can pick pretty much any number that you like. You can say 500. I was gonna go with 10, and then I thought let's go big or go home. So let's go with 500, and 500 is considered true. Okay, this is the start of something new. So we can see that numbers in GameMaker besides just 1 and 0 have truth values. Okay. We can try this with other numbers. We can try this with like 5.75 if you want to test a fraction. And we are going to see that this is also true. Okay, that's fine. If you're familiar with how C does truth values in the C programming language, you may happen to know that 0 is considered false. So 0 is considered false. And anything else is considered true, so that could be 1, that could be -1, that could be, like, what's a really big number? 1337 can be considered true. You could have -1 million. I don't even know how many zeros that is. I think that's 1 million. In C, this would be considered true. Anything that is not 0 is considered true in the C programming language. This is not the case with GML. If you were to run this, you would see that -1 million is going to be false. Okay, that's a little different. In fact, if you were to do this with any negative number at all, this would be considered false. So -1, -1 million, it doesn't matter. You could have a fraction in there, and the negative fractional value would be considered false. That's okay. We have 0 is false. Anything less than 0 is false. 1 is true. Anything greater than 1 is true. That leaves the middle ground. The truth values of numbers between 0 and 1 are slightly less intuitive. You might first expect any number greater than 0 to be true, but if you were to type in 0.1 into this condition, we are going to see that 0.1 is false. It is falsy. It has a truth value of false. And you could, if you wanted to find the crossover point, if you wanted to find the magic crossover point, you could increase this value by a little bit and see where it turns from truthy to falsy. I am just going to tell you to stop beating around the bush a little bit, that 0.5 and below is considered falsy by GameMaker, and 0.51 and greater, well, anything greater than 0.5 is considered truthy. So 0.5, that was false. If I were to say 0.500, a bunch of zeros followed by a 1, this condition would be evaluated true. This is kind of an arbitrary decision on the part of the people who designed the GameMaker language. They just decided to make 0.5 false and anything less false, and anything greater than 0.5 to be true.
Hey.
Normally, this is of no consequence. You're normally not using fractional values between 0 and 1 to evaluate truth conditions, although it does happen sometimes. Which brings me to the point of whether or not it's actually a good idea to treat any number as a true-false condition in GameMaker language. I used to hate this. I used to think you should only use dedicated true and false values to evaluate conditions in programming languages, to evaluate true statements and if statements and that kind of thing. Nowadays, I don't care. I do it all the time. It is fairly often that you will see me using a condition that is a number and using a positive number to indicate a passing condition, and a negative number to indicate a failing condition, like an error code or something, if I were to assign -1, -2 or so as an error code. Some people would still take offense at this if you were to use any old number as a true-false value. I will say, to the people who think that you shouldn't do this ever, the joke's kind of on them, because GameMaker kind of does this in the background without you possibly realizing it. So if you have an instance, and it may contain an instance ID, if you have a variable which may contain an instance ID, you can get that from something like instance create. You could get an instance ID from some of the other instance functions, or maybe a collision function, anything that would return an instance ID. And you might say, if you want to check that the instance exists, if instance exists, you might pass that into the condition. You might also use the keyword no one to represent the absence of an instance, to represent the fact that an instance does not exist in this particular case. And you might use not equals. You might say if instance is not equal to no one. No one for a very long time was basically Gmail's equivalent to null. Gmail does not have a built-in keyboard that says null, although it does have pointer null, which we're not going to talk about right now. Instead, they chose to call it no one. Again, this is just a design decision on the part of whoever made the language many years ago. And if you want to, it is possible to shorten this to, instead of if instance is not equal to null, you could just say if instance, and you could use the instance ID or no one as the truth value. Yeah, about that. So no one, as we shall see, is just the same way that true and false are macros for 1 and 0. No one is basically just a macro for -4. No one is a number. No one is not in a special instance type or anything. If you show message it, you can see that it is -4. If you do any other number operations on it, you saw that it evaluated to this condition as false, by the way. So again, -4 is falsy. If you were to do math on this, if you were to say something like type of no one, you would see that it is indeed just literally a number. And the same goes for instance IDs. Instance IDs are just numbers. They're not a special value. They're not a pointer or anything like that. Instance IDs are just numbers. So if you've ever in your code just said, had a reference to an instance and just checked directly to see if it exists with the if instance ID, you're taking advantage of the fact that all numbers in GameMaker have a truth value. This makes it a little bit weird if you were to use one of the other instance-related keywords in GameMaker, such as all. All is going to evaluate false, which is a little bit counterintuitive because you would think that, if anything, all should be true. But again, if we were to show message all, we would see that it has a number value, -3. The same goes for, I believe, global is another one. There are others. I'm not going to get into that right now. Anyway, that is truth values of numbers and places where you might have used it without realizing. So, let's see. I'm kind of treating this section down here of the code from last week's video as just a checklist of things to talk about. I am going to just remove these to remind myself that I have kind of already dealt with them. All right. Next, what about strings? So I'm just going to say value is going to equal a string. And we can check the truth value of that. I'm just going to call this variable value because I keep changing the name. We're going to check the truth value of the quick brown fox by passing it into the condition and seeing how GameMaker responds. And you can see we get an error. So not all data types in GameMaker have truth values. There are a couple data types in GameMaker that do not have truth values. Strings are one of them. Strings are neither considered to be true nor false. Strings will just break your game if you try to use them as such. Some languages like JavaScript would actually let you use a string as a truth value. I believe the way JavaScript does it is that an empty string is falsy. So an empty string would evaluate false, and a string with actual content in it would be truthy, so it would evaluate true, but I'm not 100% sure on that.
Hey.
If anything, JavaScript's opinion of truth values are even weirder than GameMaker's, so I'm probably best off to just not talk about JavaScript for the rest of this video. But anyway, you can see that strings do not have a truth value. In some ways, it would be helpful if they did, if you wanted to just check the existence of a string real quick without having to use like a type of or an isString function or something, or comparing it to undefined. But it is what it is. Strings do not have truth values. Okay, greetings from the future. So shortly after I recorded this video, I, by total accident, found that there is a little bit of, let's call it additional weirdness that you can do when it comes to truth values and strings. So if you have just a regular string, whatever I had in the initial recording, if you have just a regular string, and you try to get a truth value out of it, Let me just type this out. This isn't gonna work because as we saw in the video just a minute ago, strings do not have truth values, and this is gonna cause the game to break. Okay, that's I talked about that. That's fine. However, if you have a string which contains a number, let's just make it the number 1. And if you run the game now, and if you try to get a truth value out of this, you will, instead of having the game crash because there is no truth value in strings, a string containing the number 1 is truthy. Okay, if we're going to think about using the truth value rules that regular numbers have, let's try 0.5, or let's try 0 first and then 0.5, and we can see that a string containing 0 is falsy. All right, that checks out. If you were to do it with 0.5, it would be falsy. If you were to do it with just something that's a hair over 0.5, it would be truthy. These follow the same rules as real numbers. So what's actually happening behind the scenes is the GameMaker is attempting to cast these strings to numbers. If you were to let's give it like an exponential part. Let's try like 1e7 to represent an exponential part. GameMaker is attempting to cast these strings to numbers before evaluating their truth values, and if it's a number that's truthy, I haven't actually tried infinity yet. If the number that the string contains is truthy, then the string will be truthy. If the number that the string contains is falsy, the string will be falsy. As you can see, infinity, the text is truthy here. And if the string cannot be cast to a number, if you try to do something like real the string, you would get an error because you can't convert the string to a number. And likewise, the truth value of that would be undefined because you can't convert that to a truth value. I see that the GameMaker compiler is just yelling at me and not letting me do that at all. That's fine, I guess. So this is arguably even worse than anything else that I've talked about when it comes to truth values with strings. JavaScript's strategy of having any non-empty string be truthy, for example. At least there's a rhyme or reason to that. It's basically checking for a null value. Here, converting to a number before trying to get the truth value out of a string, I don't like that at all. I actually found this by accident when I was trying to figure out why something wasn't making my game crash, because I was accidentally trying to use a string as a boolean, and I was trying to figure out why, and then I noticed that the strings were containing numbers and that the numbers were having truth values. Yeah, you can form your own opinions about this down in the video comments. I don't like this. I would rather have either strings not have truth values at all, or at least just be like a null value check. But just for the sake of not accidentally omitting information from this video, there you have it. Strings containing numbers do have truth values. I am sorry for cursing you with that knowledge. You may all carry on with your days now. I will now be returning to the previously recorded video. Next, I'm going to talk about arrays before I talk about structs. So arrays are a thing that you can use in GameMaker. Again, referred to last week's video. We can just create an array like this with an array literal. I can run the game. We are going to see the truth value of arrays, and we can see that we get another error message here, illegal array use. Arrays also do not have truth values, much like strings, and again, much like strings, it would be kind of convenient if they did, if you could just check for the existence of an array by passing it into an if statement, but you know, to be honest, it might be for the better that arrays and strings do not have truth values in GameMaker, because I could see a lot of people screwing that up. JavaScript, I said I wasn't going to talk about JavaScript, but JavaScript is kind of infamous for letting you get away with doing anything, even if it doesn't actually make logical sense in the language. It's kind of one of the reasons why there are just so many memes about JavaScript out on the internet. Anyway, let's see. We've talked about arrays. Next, let's talk about structs. So a struct in GameMaker looks like this. They are a relatively recent addition. I think by now they've been out long enough that most people are aware of them. If you would like to know more about structs and how they're new, as I often do, I will plug a video that I made last year about them. See the video description or see one of the pop-out cards that should be popping out of the top of the screen right now. Structs are always true. Structs are always truthy in GameMaker. You could pass a struct, it doesn't matter what it contains, into an if statement, and it will always evaluate true. You could also pass an empty struct into the into the if statement, and you can see that it will still evaluate true, even though it doesn't actually contain anything. As long as this value contains a struct, it doesn't matter what the struct itself contains. It will be truthy. That's pretty straightforward. What other data types do we have? Undefined. Undefined is a fun one. I really like undefined. Undefined is, it's weird to say that you like a particular data type in a computer language, but I really do like undefined. Undefined is kind of what null, or what I should say, no one probably should have been from the beginning in GameMaker language. Undefined is a special data type. It is extremely useful when you want to indicate the lack of a presence to anything. It's kind of versatile in that you could compare it to anything with equals equals or not equals, and it'll just work. Unlike in cases of when you're trying to like do math on a string, or you're trying to do logical operations on a string, and GameMaker would just crash. You can compare anything to undefined and it'll just work. In a lot of ways, undefined is kind of the opposite of a struct in that it will always be falsy. That kind of makes sense. There's only one value undefined can actually have, and that is obviously undefined. And in a lot of places, the thing that you would use it for would be for to indicate the absence of something. So it makes sense that if you are checking if something exists and you have it set to undefined, that it should return false. Okay. Oh, down here, I see I also have some special numbers. There was a nan, which I talked about in the last video, and there's infinity. First, let's talk about infinity. Infinity is a number, and infinity behaves just like a number. You can set it to true, or you can set it to true. It will evaluate true. It is truthy, I should say. You can also have negative infinity, which is the opposite of infinity. So this is like a negative number divided by 0 or whatever. And negative infinity will evaluate false. So again, just like any other number. I believe that's what I was doing down here. Negative infinity. Negative 5 divided by 0 is negative infinity. There's also the matter of nan, which is always a fun word to say, which is not a number. Nan is technically a number. It's just kind of a special number in that it represents mathematical operations that can't happen. Like, I believe 0 divided by 0 was nan. Nan is going to be false. That probably won't be too useful to you very often, because I doubt that you'll find yourself in many situations where you're trying to get the truth value of something like the logarithm of a negative number or something like that. But regardless, nan is false. That's it for the special numbers. Let me delete those. Pointers. We're moving through this now that I've gotten like long-winded stuff out of the way from the beginning of the video. Pointers. So pointers are something that you'll rarely see in GameMaker. There are only really like two situations where you might use one, which is getting the address to a buffer so that you can pass it to the DLL, and getting the address of the game window in the computer memory so that you can pass it to the DLL. If you do that, because that's not something that you're going to do commonly. Regardless, you can create yourself a pointer with a PTR function. I made a video a couple months ago about all the fun things you can do with the PTR function that don't actually involve using pointers. But regardless, we can just turn any old number into a pointer. We can say 0, we can say 5, we can say any other number, and we are going to see, and this is kind of enigmatic. Pointers don't have a truth value. You might expect that they do if you've ever done anything at all with C or C++. You might expect that pointers do have a truth value, and that a null pointer being 0 would be falsy, and an existent pointer would be truthy. But in GameMaker language, that is currently not the case. Pointers don't have truth values. You can't pass them into if statements. I don't know if that's an oversight or not. You can use the special value of, I believe, pointer null to check if a pointer is null or not, and this should work. 0 is a null pointer, and anything else would be an existent value in an existent address in memory somewhere, but pointers themselves do not have truth values. Again, I highly doubt this is something that anyone's gonna have an issue with at any point, because it's so rare that you actually use pointers in GameMaker. But in case you're ever curious, pointers don't have truth values. I was surprised when I found that out too, because it is a little bit unexpected. Next, we have functions. Functions, as you would know if you watched my last week's video, are indeed data types. There's two ways to define them. You can say function add, or you can say add equals function. They both create a function. Just one is global and one is stored in a variable. So if I were to just borrow this and say value equals this function. I'm going to get rid of all that down there so that there's no screaming syntax errors. If I were to say value equals a function, and let's get rid of that pointer null nonsense because that's kind of not important anymore. Functions are truthy. Again, this is something that you probably won't be doing very often, but if you ever try to pass a function by reference and you want to know if you've actually passed a valid function or not, you can just check its value with a conditional, and you can see if it's truthy or not. Functions themselves are truthy. It doesn't matter what they are. It doesn't matter if they are kind of just empty. And yeah, let's stop the running instance and run it again. It doesn't matter if you just have an empty function. It's going to be truthy, much like structs. Semi-related to functions, there is the matter of methods. I would like to make some other videos describing methods in greater detail before I like talk too much about them, but methods are also truthy, just the same as functions are, if anyone's been wondering. If I were to say a method bound to an empty object containing a function, so value now contains a method which is bound to nothing instead of a function, and the method is truthy, just like functions. Okay. If you had told me like 5 years ago that I could talk for 15 or 20 minutes or whatever about just truth values, I probably would have said you should go waste someone else's time, but here we are. So before I go, I'm going to just say a little bit more about truth values. If you want to see if something is truthy or falsy, you can of course pass it into an if statement like this, and that will let you know. If you want to go the slightly longer way around, you can also attempt to negate the value, and the logical negation operator, the exclamation point, will turn true into false and false into true. So if we try to run this code now, we're going to see instead that this condition is false because true negated is going to be false. You can do this twice, and this is one of the dumber looking things in code that you might run across, but you are perfectly free to use two negations, and that will return it to the original truth value, but it will now be instead of the original value in this case, because it contains a method, or just a function or a struct or whatever else you gave it, it will contain a true false. If I were to get rid of this and say just show message, double negation of the original value, you're going to see 1. 1, as we know, is true. If you were to do it 3 times or whatever, it would be false. If you've ever taken a formal logic class or anything like that, or anything involving proofs, you've probably heard of double negation before. This doesn't really have a name, as far as I'm aware, in computer science. I like to call it the bang bang operator because, for reasons that I do not understand, Unix sysadmins like to call the exclamation point the bang operator, and it's just kind of fun to say bang bang, like finger pistols or whatever. I've heard people call this the truthinator operator, which is in no way, shape, or form the official name, but it sounds funny. So if you want to call this the truthinator operator to turn any given value with a truth value into a 1 or 0, true or false, then you can do that. There is also a function called bool. Bool is much like the int64 constructor or the pointer constructor in GameMaker, and it will attempt to turn any given value into a boolean. It kind of doesn't always work. I don't know if it just never got updated after like GameMaker 8 or whatever, and it doesn't account for some of the new data types, but if you try to pass a method or a function into the bool function, it'll return 0, which doesn't seem terribly useful. It'll do it for a regular function too, won't it? Yeah, a regular function which has a truth value of truthy will be 0 if you try to pass it through the bool function. Let's make that an empty struct. Alright, an empty struct is also 0. What about something that doesn't have a truth value? I haven't actually tested this. So if you try to pass an array into the boolean function, will it crash? It'll crash. Alright. Don't use the bool function, it kind of sucks. Okay, those are truth values. I try to avoid like abusing them when I make tutorial videos. I try not to say like if struct just in the condition without having an undefined attached to it or something like that. I try to avoid that because it's can be a little confusing for people who've never seen truth values before or never dived deep into them. But if you know about them, you are perfectly free to use them. There's no reason not to, as long as you understand what they're doing in your code, and I guess by extension, as long as anyone else who might want to read your code can understand what you're doing, then it's perfectly allowable. It's not like you're taking advantage of a bug or anything like that. I've considered submitting a feature request to GameMaker to give things like strings and arrays and I guess now pointers truth values so that you can use them as truth values, but I am not actually going to do that because, as I've said, it may cause more problems than it'll solve if you can just put a string into an if statement and then someone who's maybe not super experienced with computer programming and doesn't notice that they did that, it could cause problems for unexplained reasons. Anyway, that's it. I don't have any code to distribute for this video. I guess the only thing I would say is if you want to test the truth value of something, you can use the bang bang operator or the truthinator or whatever you want to call it. Otherwise, I hope you found that interesting. If you've never thought about this before, I hope it's given you a slightly deeper insight to what's going on inside the computer. I have a Patreon, so if you want to contribute towards these videos being made, there are links to that in all the usual places. Otherwise, I try to post a couple game dev videos a week. One Let's Make a Tower Defense game as part of a long-running series, and one tutorial more like this. I hope you all enjoyed that, and I will see you all later. Special thanks to David Key, Edward Holt, Emily Koyo, Posho, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page in the video description to join the fun.